Don't feel bad. I don't feel lonely. I'm just glad it's over.
Welcome again to the Southwest Climate Podcast. As always, the pessimistic or optimistic Mike Crimmins. Sometimes you go either way, man.
I know. Well, I'm optimistic that the monsoon is over. How about that?
Well, you just gave away the
Oh, I
punchline.
mean, okay. All right, let's roll it back.
No, you're optimistic. So you ended last pod with like, I think you said, and I actually started parroting it because I think you're right. You were like, I'm kind of glad it's over. I want to
So
come back to this.
yeah, no, we've got a lot to talk about because I think the last podcast too, I'm pretty sure I was pretty grumpy about how stuff had shaken out, and it didn't get any better. And I made a pronouncement at my house and like it's not going to rain again until probably November, and I was almost right, but not quite.
We had a little something something last
A
week.
little, and it was just enough to like make a mess of, like dirt on your car sort of thing, but not enough to like water any plants.
All right, so let me prelude this a little bit. So I think there's a big question that we want to tackle, and that is what the heck happened to the second half of the monsoon? It literally fell off a cliff early. Okay, so that's earlier than usual, let's say. So we want to unpack that a little bit. And I'm done with September as part of the as part of the monsoon. So we'll come back with that.
Yeah, yeah. Are you ready to like kick it out of the like we're going from 3-period ice hockey to just 2-period.
Yeah, halves.
Yeah, two, just go to halves. Just
I'm
July, August.
I'm almost to the point where the monsoon fantasy forecast game next year is not going to
Yeah.
happen September.
Wow.
Yep.
Holy moly.
Yep.
Okay. I like this. Yeah.
Done with September.
Is this like Pluto's not a planet anymore? Like this is going to be that controversial? Like September is not a monsoon month anymore?
Well, that's a tough one because I think I would have a lot of people on my side. A lot
Yeah.
of like you'd have the scientists maybe more on my side, but then the people who think about like impacts and risk communication, it would I think it would fall down those two lines.
I think you're right.
And most people wouldn't care. Let's
I
put
think I don't Tucsonans and Arizonans and New Mexicans, they care about this would be, I think we're breeding controversy as we always do.
Yeah, there's a third topic here that we want to hit, which is, one of the larger stories, I think, nationally, well, globally, if you will. Not politics, Mike. Not
Thank, thank
not
goodness.
football.
Okay.
Yep.
Major League
But
Baseball.
the Atlantic hurricane activity or lack thereof.
Yeah. Yeah.
So we'll hit on that. And also, we'll wrap it up with some early winter forecasting by Mike Crimmins. He's going to
Oh
do
no.
eyeball regressions,
Yep.
principal component analyses on your TI-81 calculator.
I gave my TA81 to my son. He's using it in high school, and he can't believe that people ever use these things.
That's awesome. All right, so I'm just curious if you polled a bunch of people in Arizona, New Mexico, do you think that the majority of them would call it a good, an okay, or a bad monsoon?
Oh man. Okay, so this goes back to our whole ongoing, almost over a decade long idea that a lot of monsoon opinion is driven by population density.
Yeah.
And so Phoenix, not super happy with how the monsoon shook out. Half of Tucson is, and then I think if you went to other places like Albuquerque or Flagstaff, I think you're going to get another mixed result. And when you look at the maps across the region, it's kind of a mixed bag as well. So I'm not sure you're going to get anybody who's like you. I don't know. You may find one person be like, "That was the best monsoon I've ever seen." I think they're going to be hard to find though.
So you think it would lean toward it's bad? I think
do.
by population wise, if that probably would like,
Population density and miserable people, probably not super happy.
yeah. So I was thinking about this. I think it would go the other way, actually,
Interesting. Okay.
because it wasn't last year. Right. And I think that's what like people's frame of reference is.
Yeah.
I mean, this is all like conjecture, obviously, It would also be interesting to see which of the last 4 years people remember more. Like, was it or last 5 years rather? Was it like 2020, which was terrible, 21 or 22, which were good? 21 was historically good in some places. 22 was historically good in some places too.
Yeah. Yeah.
23 was like 2020.
Yeah.
Uh, and then this year was, yeah, like it wasn't last year, but it wasn't the good years either. Anyway, I'd be curious to see where it falls. But I think, yeah, I think people would generally lean toward it being okay or good because it wasn't last year. But anyway, so maybe let you sort of started this, Mike, just sort of giving a recap of where we are. And I think so. We're taping this on Friday, September 20th. Like technically, the monsoon isn't over, but I'm calling it. There's not much on the 10-day, 6 to 10 day forecast. 1 to 5 day and 6 to 10 day forecast. Like so, I think it's fairly safe to say that the picture as it's presented now isn't going to change all that much. Would you agree with that?
I do. Yeah. I mean, okay. So and we'll either get to this now or get to this later, but I kind of felt like in late August we were done, and that if we were going to get any precipitation, it was going to be a tropical storm, and that's what happened. And so if we're going to get anything else in the next 10 days, it's going to be something that spins up in the East Pacific and is able to make its way up here. But I'm skeptical as well.
Yeah, so let's get to the tale of two halves, monsoon halves in a minute. But so I summarized the picture last month and things really haven't changed. So looking at a map, Mike, this is from your, monsoon page, which everybody should consult for cool graphics and other things. And so, yeah, let me just sort of describe the percent of average precipitation from June 15th to September 19th, right? This is the day behind. All right. So basically in Arizona, there's a section, let's say from Tucson up northeast to Safford, down to the border, let's say that right close to the Chiricahuas, and then back west towards Cerro Vista and up to Tucson. So that like trapezoid, I think that might be the the geometric shape is like there's areas above average and close to average. So that's sort of and that's kind of what you would expect. I mean, that's sort of like the main monsoon area in Arizona. And then, largely around Flagstaff, Prescott, that sort of area is another similar, sort of decent to more than decent location of above average rain. And then the Four Corners area, that's sketchy in part because there's like what? I'm looking at the map here, like 3 to 4 total stations up there that you're drawing off of.
Not a lot.
Yeah. So New Mexico, then it's kind of like northwest, north central to northwest, New Mexico, and then like little parts here and there that are decent to above average. Yeah, maybe there's more area in New Mexico where it's like closer to average than below average. I guess in looking at the map, if you tallied that, which you have on, from this gridded data set, you've sort of looked at, well, what's the percent of the total area like that's way below average, below 75% of average, that's on the order of 40%. Flip it though, like the total area that's like way above average, maybe not way above, but above average. well above average, above the 125% of average, and that's only about 15%. So tilted toward the dry for sure in terms of area. And then I also looked at, so you've piped in about 105 stations from around the Southwest and calculated, it's in near real time, derive the percent of average from June 15th through September 19th, right? And 48 of 105 stations are below average, or sorry, above average. Yeah. So, but those are more heavily like if you look at the distribution, like there's a lot around sort of the Flagstaff area, the Mogollon Rim, there's a lot of Southeast Arizona, and there's a lot in New Mexico. The majority of them are in that sort of northern central half. So, it's probably not the greatest picture spatially. But again, I think you putting all of those things together, and yeah, we're sort of a lean toward like what's the word here? A lean, like less quality monsoon, less vigorous monsoon, less less
Not generational. So Zach, I was waiting. I mean, are you going to drag out generational monsoon?
No, this is not a generational monsoon. It is in one respect, though, which I'll get to in a minute. It is generational. So how are we defining generational? Like,
I don't know. I love it. I love it when we have a good monsoon and you call it generational. Like that's like the highlight of a good monsoon for me is when you drag that out.
Well, I have one data point that actually is generational.
And I'm afraid I know what it is.
Which we'll get to it. I don't think you do because
okay.
It took me 2 hours to get to get it.
All right, cool. I'm excited that. Yeah.
So what else, Mike, spatially sticks out to you? Anything spatially sticks out to you that might actually like reveal some sort of interesting sort of dynamics, synoptic climatology, anything like that?
We talked about this last month, and we can kind of talk about the precip now because it really hasn't done much in the last 30 days. It's been very, very isolated, right? So I think there are some stations that got underneath some good storm events, single day storm events, and those are typically what put those locations above average or near average. And so it's not, if we look at some of the mapping, and the mapping is really difficult because it's all, for the most part, all station driven and then interpolated. So you don't really get a good sense of like storm tracks and that kind of stuff. One of the products that I look at is a radar derived product that NOAA puts together. And so that's got a little bit more spatial granularity because it's both station data and using the radar estimates during events, and then tallies it up over a day, and then we can tally it up over the whole season. And that product has got a lot of like little dots all over the place, of very isolated cells, but then a lot of areas in between those dots where it just didn't rain, right? Like the frequency of the events was much lower. And so those are the areas that fell behind. So it's instead of a season like 2021 or 2022, where you have these large widespread events, heavy rain over large areas, and they maybe will move. We just didn't, I'm trying to even think about a single event where we had something kind of large scale that moved around the whole region.
Wait, so I want to go back. So what are the dots? So you're looking at a radar product that's basically telling you where a significant storm cell theoretically dropped rain.
Yeah.
So you could have it more than one day. I mean,
yeah,
it could be on the same day in more than one place.
Yeah. So one of the series of maps I make some statewide maps, both for Arizona and New Mexico, and it's using the it's MRMS data, multi-radar, multi-sensor product. And this is a long-standing, continually improving product that NOAA, and it's radar derived. And so like during an event, the radar is scanning the storm and is converting the reflectivity to a rain rate, and then just just over time that is a depth. And then every day that's processed into a daily total. And then we can look at that daily total from June 15th up to present. And we can also then calculate a difference from average using a longer term gridded product. And so, which is really interesting and nice about this is that if you have real isolated cells, during the monsoon season, say like it rains in one corner of Tucson and not the other, that will be picked up by the radar and preserved. And also in areas that we just don't have gauges at all, it's actually going to capture those events. Again, it's imperfect. It's an estimate because the radar sometimes will overestimate what actually reaches the ground. Sometimes it evaporates, those kinds of things. But just looking at the picture, the pattern of the rainfall is that it's very heterogeneous or very spotty. And so very spotty would be indicative of very isolated storm events. So you can have, a very small set of grid cells that are 4 kilometers. So maybe like a 10-kilometer area that's above average, and then around it in a circle is below average. And that's the total over 90 some days so far in this season.
So would that spottiness, we've talked about this a lot, not recently in the last couple of years, I don't think.
Yeah.
But we at one point I remember like, could we come up with a spotty index? But so would that be the result of like weak winds?
Yeah. 100%. Yeah. So it's like
that's like the driver of spottiness.
Yeah. I mean,
it's not enough. The wind by week. Maybe we should just describe that a little bit. So it's like, it's basically just like the strength of the winds at like the steering at 500 millibar height is like weak, light, and it's not steering the storms in any particular way, but it's also like that somehow relates to its inability to propagate, right?
Yep.
So how does that work then?
Yeah, so you can think of like, this is such an interesting thing that you and I have been struggling with over a decade now of the differences of these monsoons, right? So 2020 was the one that stands out to me as that's what happens when there's really no moisture, right? It didn't rain anywhere. You didn't have the spotty issue. It just didn't rain. Like we just didn't have the moisture. And then we've had other years. Last year, it had some similarities. And the very beginning of the summer of 2021 or 22 started off kind of weird too, where it was like, there's plenty of moisture, but there was very little sort of organization or steering with that. And so then with a very moist environment, you're going to end up having the terrain will drive a lot of the convection. So it's going to be the most unstable. So you can end up having that. And you can end up on the high terrain having these kind of pulsy type storms. So the convection is very isolated and it pops up into a tower. And if that tower isn't have some tilt to it and some movement with some wind shear, then the rain will fall through the convective tower and squelch the own thing. So you can end up having a good pulse of rain in a spot, but it won't go anywhere. And then the outflow from this storm can then cause another convective tower to pop up nearby, but it might not move anywhere. And so you end up, and this can happen down through the valleys and and it's also why the further you get away from topography, it's harder and harder for it to rain. And that's effectively why Phoenix did so poorly, is that there wasn't much shear coinciding with good moisture and any kind of like upper level, like inverted trough or easterly wave or something like that to really organize a large, like a rim shot, like a large organizational cluster of outflow storms that will drive into the desert, pop up a nice line of storms, and then, push their way all the way out into Western Arizona. So you end up with a map that's like near the mountains, kind of did okay. It's funny too. It's like even around Tucson, that wasn't even the case. The Catalinas, just our mountain range north of the town here, they barely squeaked out average in most of the things that I've seen as well.
So what then would influence the strength of the winds aloft?
It's going to be the upper level flow pattern, and it's going to be the position of the subtropical ridge and basically that monsoon high. So if you've got a monsoon ridge that's pushed up north through the western US and that Four Corners high is in the Four Corners, and you've got a strong kind of upper level gradient from that high pressure to say there's low pressure in northern Mexico because of easterly waves, that's going to enhance the gradient and it's going to cause those upper level winds to blow a little stronger from east to west, and that will create some shear. That's kind of like one. There's a lot of different ways to have that kind of pattern originate, and it'll move the storms around in different ways.
But I wonder if it's, so how do I want to say this? Because you can have the position of the ridge in a sort of favorable location to have high moisture, but still have not great strong winds aloft.
Yes,
right?
absolutely.
So I wonder if it's not just you were sort of alluding to this. It's not just the position of the ridge, but it's also its relation to other upper level atmospheric features that create gradients.
Yeah.
Right? Because because we've been in situations where maybe even at times this year, probably at times this year, where the ridge was actually in a good favorable position north, but we had those weak winds. So
yes, and no, and this is a
so it's not just the ridge position.
no, I mean it helps, right? Okay, so a couple things here, like that canonical Four Corners high, like that typical position, the thing that we're kind of like, we colloquially known it, it's called that because of its geography, right? Like we look for that on a weather map. If that ridge is in the right spot, but the gradient is weak from the ridge to the south, then the winds might actually be weak. And this was something that this was a kind of a climate change aspect to keep an eye on, because this was one of our colleagues, Chris Castro, and I can't remember if this was, I think it might have been the Lammers paper. He had a couple of grad students write some papers on just sort of like establishing if there's been changes in the monsoon and how we might want to think about it in the future. Was that if the ridges actually were in the right spot and strengthen and expand, that might actually, even in the right spot, the gradient might be
the expansion would reduce the gradient.
Would reduce the gradient, and it would also increase the upper level temperatures. And so if the upper level temperatures at 500 millibars, 15, 20,000 feet are too warm, then the lapse rate from the surface to that height may not be good enough or steep enough to actually help with our convective potential. And I'm not saying that's exactly what we saw all summer. Honestly, what I saw a lot of this summer was the ridge wasn't particularly, it was strong in some periods, but it would often it would back off and weaken, and the ridge would flatten out and would rebuild overhead. So it would kind of rebuild over southern Arizona, central Arizona, and western New Mexico. And what that does is, just like you said, the moisture, we didn't have any trouble keeping moisture around for the most part. We had that big flush, big slug from the east in June, but that actually subsided, right? And we talked about this last time, that I think the real start of the monsoon was actually probably the second or third week of July, when we actually then started to see Gulf surges and rebuild the moisture. And once we rebuilt the moisture into the Southwest, we held on to it pretty evenly. And
not for very long though.
Well, I know that's the thing, right? We'll get to that. Is like once we built it in, we didn't have any breaks. Like we had no breaks in the moisture from day to day, but the ridge would kind of retreat overhead, and when it would do that, you'd lose your steering winds. So you had a lot of moisture and convective potential just because of that moisture. But the storms kind of sucked, right? I mean, they would pop up, they'd be quite small, and if you were under them, and and this is kind of the weird thing too, is like under that weak flow, I do think there are favored kind of like topography. There's favored locations of some of these storms to form and then flow even under weak winds. Like they'll just kind of wander. And then if you're kind of near those spots, you're going to get repeated rain events. And we saw this in Tucson where even under that kind of non-ideal situation, there were repeat events where people were getting 1-2 inch events like every couple of days. And those locations ended up having way above average monsoon, but the gradient east, west, north, south from those locations, it dropped off really quickly. So the haves halved for sure, but there were a lot of have-nots in this monsoon.
Yeah, so I'm looking at rain log right now, and Tucson, central Tucson was the sort of big winner. For the most part, across the metro region area, rather, it was somewhere between 5 and 8 inches, which is, at the airport is like what, 6 inches?
Yeah, so the airport to date is slightly above average, right? And I'll tell you, I had 4.5 inches, and I got more rain last summer than I did this summer. And that's kind of how it happens. And it's interesting, just like we're the Southwest Climate Podcast, and we end up focused on Tucson too much, but Tucson is kind of a really interesting case study in the pattern of a monsoon across a small area. Is Oro Valley, which is to the north of Tucson, hugs the Catalinas. That is, in some years, you and I would complain about how much rain Oro Valley would get because the storms would form on the Catalinas off of Mount Lemmon, and they would track to the west, and they would just get rain after rain. But that place was one of the driest spots in all of Tucson. We have many rain loggers there who've had less than 2 inches, and being that close to the mountains. And then you go 5 miles south of there to the Tucson Mountains, which are not a substantial topographic feature. Ton of rain loggers with 9 to close to 10 inches. Far east side of Tucson, where I live, in my neighborhood, we got about 4.5, but north of our neighborhood, there's 7-inch reports, and south of us as well. So it's just like, it's so interesting how the spatial gradients can be so extreme during the monsoon, and they often go unnoticed because our monitoring it's really hard to keep up with this kind of spatial granularity.
Yeah, so thanks to a couple of rain loggers like my neighbors, I know I was close to around 8 inches. So
yeah, I mean, and we got the CocoRez program across the rest of the country and across the Southwest, and then we're constantly trying to like piece together stories with all of these different rain gauges.
Yeah, so I'm downtown. I'm close to downtown Tucson. All right, so couple thoughts. One is, yeah, you mentioned it that we often focus too much on Tucson, and today I was thinking about that. I was like, man, if we just had like an area, like a station that was like highly correlated, like with the bigger picture, like that we could use.
The single index station.
Yeah, I think like
yeah, right.
Tucson's probably not bad for that.
Yeah.
But I wonder what the highest correlation would be like among other stations.
Do you mean like you're talking about across the whole like Southwest?
Yeah. Like
oh man, not good. I mean, like we have trouble characterizing Southeast Arizona, and now I'm looking at all of Arizona, and then I'm like New Mexico, we want to give some love to as well. And I mean, just like the subtle nuances have been
that paper that we talked about last time, and I'm forgetting it. But they looked at 5 areas across Southwest, and then they chose those 5 areas, which admittedly were like strange, right?
Oh,
like,
the JANA paper on the moisture sources.
Yeah, exactly.
Yeah. Yep.
And they selected those areas because they were the most correlated within a specific region. And anyway,
Yeah, that's right. That's a good point.
but not great correlation anyway. That's neither here nor there. So okay, so the ranks, if you were to say that there's going to be zero precipitation for the next 10 days, which I think is likely, then Tucson will come in as the 40th wettest.
Interesting. Yeah.
Yep.
Yeah, that makes sense. Yeah.
Wait, but it's 76 years, so it's I painted that optimistically. 40th wettest out of 76 years is still like what, the 35th driest? So
Yeah. Yeah.
so I should have done that differently. Phoenix is the third driest out of 77 years. Flagstaff, 19th driest out of 75 years. Las Cruces, second driest out of 132 years. This is your data, so you're scrunching your brow there.
Yeah, I'm looking at the official rankings off of the I'm looking at the 3-month ranking. No, I'm game here.
You're looking at something different. Yeah, I'm looking at your data, your station data.
Yeah.
And sorted it by total.
Yes.
And then counted and then figured out from that the rankings. All right, so and then Albuquerque is basically in the middle, 64th driest out of 132 years. So the rankings, let me do that again. I can't do the backwards math here. 36th or 7th driest for Tucson out of 76. Third driest for Phoenix. 19th driest for Flagstaff. 64th driest for Albuquerque, and second driest for Las Cruces. So yeah, mixed bag, right? Like Phoenix is definitely the loser here. And if you look at rain log, I mean, there are a few areas north Phoenix, northwestern Phoenix, where it's, an 1.5 to 2 inches. But a lot of like below 1 inch. I don't know what what do we have at the airport? So for Phoenix, we've had what? Less than 1 inch. So 3/4 of an inch at the airport to date.
Yeah. I think I mentioned this last podcast, but I still can't get my head around this. But Sholo, which is up on the Mogollon Rim, they have an official station at the airport. It's the driest on record for the last 30 days. So this would be June 19th through September 19th. They have 57-year record. It's the driest, 1.91 inches. And I look at rain log, and so there are a couple of observations about like 2 to 3 inches. So it kind of
just south of that.
And then there's a giant one in
Pine Top.
So I'm wondering if this is like helping prove our point of if you just some of these gauges are just unlucky, right?
I think that's right.
Because it's not regional, right? Like there aren't expansive holes. There are tiny little holes and tiny little bullseyes of
particularly going back to what you said about earlier about the spottiness. I mean, it's even more accentuated in a season like this.
Right.
The other thing I was thinking, like you mentioned sort of another defining characteristic was that there were few but intense events that were probably driving the totals.
I think that's right.
Yeah, I wonder if like a cool index would be just like how many events did it take to reach 50% of their total? Although that might be weird if you have low totals, right? Like
So one of the things I calculate on both the regional and the statewide maps is something called the intensity index.
Oh, you've done this.
Well, it's not quite what you said, which I think what you said is even cooler, but the intensity index is the total precip divided by the number of days it rained. And so what is interesting, and the problem is that it doesn't have any kind of climatological context, like if it's different or not. But I know from looking at it over many years now is that even precipitation over time tends to, your intensity index is lower, right? And then if you're getting a lot of your rain in single events in few days, then it tends to go higher. And so the color ramp I use is a little weird. It's like yellow to blue to orange. And so it leans blue this year, which means that it's leaning towards a higher intensity index overall, which again, I think is indicative of what we're talking about here.
Interesting. Yeah. All right. Okay. So to a main question, which is the monsoon, one of the there's a few defining characteristics this year, right? Like we talked about this last time, the early onset that was Alberto fueled. I think it was Alberto. I'm forgetting if it's a feminine or a masculine name.
Well, I don't know if it's Alberto or was it Alberto. I can't remember.
No, it was something. Whatever.
Yeah.
Whatever. It was like the first tropical storm because it had an A.
Yeah,
right?
there you go.
And Beryl was next.
Yes,
It doesn't matter. So, so that sort of drove the early onset. We had dew points that like crested above 65, on the 22nd of June. So that was one thing. Another thing is that the monsoon basically went away. If you look at dew point, you look at rain, right? Like basically went away August 24th, 25th.
Yep.
And we had this period. So you were saying, well, if you discount or forget about, Alberto's influence, that spike in moisture that happened in late June and sort of look at when the moisture content regained itself after a brief dip, that would have been July sort of 14th.
Yep.
And then it basically ended on the 25th of August. So a 5-week monsoon. So, and this moisture level, it's not just a Tucson thing. I mean, you see it in Flagstaff data, you see it in Yuma data, dew point data, you see it in Phoenix data, things that dew point temperature sort of craters August 25th. So we were heavily skewed to the June, July part of the monsoon this year. So thoughts on that, like why it cratered?
Well, the monsoon, okay, right? We've been saying this for a long time now, but the progression of the subtropical ridge is that in the movement of it up to the Four Corners High is that upper level shift in wind direction that is the monsoon, right? I mean, like we have to have some seasonal wind direction shift. It really does start to lose its steam and wane, and that ridge starts to kind of wobble around or retreat south a little bit, or off to the east or off to the southeast. Typically the later part of August, and it just fell apart really, really quick. And so we ended up having let me pull up some maps to kind of talk myself through this. So just as you were kind of describing that period from July kind of 14th, 15th, all the way through August 25th, we ended up having, we were under that ridge, moisture is kind of locked in here. But as soon as that ridge started to retreat south, and we ended up having a pretty vigorous kind of early fall storm come through the Pacific Northwest on the 23rd and the 24th. It dug south and actually started to encroach on northern Arizona. And actually, do you remember hearing about the flash flooding up at Lake Havasu? Or not Lake Havasu, at Havasu Falls.
Yes.
Up at Wallapai?
Yep.
So that storm system in the Pacific Northwest brought in basically some frontal dynamics over northwest Arizona and basically sparked a couple of days of very intense localized thunderstorms that first set up on the 21st, 22nd, that kind of got some very locally heavy rainfall, and then another round on the 22nd or 23rd that actually caused the flash flooding. And so that was actually the beginning of the end, was that storm system kind of coming in there. And so that is going to end up interacting with the moisture that we have, but it's also going to shift the wind around from the upper levels out of the southwest. And that's going to end up being dry air off the Pacific. And it's also going to shut down our opportunity to end up having moisture come in from the Gulf of California largely. It's going to shift the wind direction. It's usually come from the south to the north, up the Gulf of California, up the Colorado River. It's going to reverse that flow, and it's going to flow the other direction. So it's going to shunt that moisture back south. And so pretty quickly, with the passage of that trough, we ended up having the subtropical ridge get shoved way off to the southeast. We were kind of under generally southwest flow. And as soon as you hit that southwest flow, even in August, it's pretty much the end. You will end up having some kind of the ridge will rebuild, and you might get a little slug of moisture, but you really won't. It really is not monsoonal at that point. So given that shift right there on the 23rd, 24th, by the end of August and into that first week of September, the dew points, at least in Tucson, they absolutely cratered, right? We were back down to daily average dew points at Tucson on September 10th was 32 degrees Fahrenheit, and we hadn't seen 32 degrees Fahrenheit since early June. And so that was like definitely pre-monsoonal. And so that was it. I mean, that was the monsoon really did end that third week of August.
So I'm glad you brought up the dew points, because this is my generational statistic, and I'm actually not sure it's generational. But so I looked at the average dew point temperature between August 25th and September 11th. So that's just 3 weeks. I wasn't really cherry picking the data. I just was like, 3 weeks is long enough to get like a decent average. I could have done it out to September 20th if I wanted to. But anyway, so again, this is for Tucson. It was the average over that 3 week period was the fifth lowest on record, and that record went back to 1952.
No kidding. Wow.
And it was the lowest since 1979. Yeah.
So
that's my, I don't know if that's generational. I think generational has to be like what, one in 25, like, right?
Yeah.
So it's not quite generational, but yeah, so it doesn't happen. This cratering doesn't happen as quickly or as severely, I should say, very often.
No, not in that September. So I think I always say this every year, but I have this weird attachment to dew point. Like I obsess about dew point. And one of the reasons I obsess about dew point is that we have an air conditioner and a swamp cooler, and I prefer the swamp cooler. And so I'm always trying to like not turn on the AC until it's too miserable. And then as soon as the dew point drops, and I literally am watching it every hour, and I watch it change throughout the day as I turn the swamp cooler back on. So that 31 degree in early September was unbelievable gift if you're running a swamp cooler, because the house is open and this thing is pumping out cold air, and life is good.
Dan walked into my office this morning and was like, Mike's talking about his swamp cooler again.
I am a crazy old man. I went on about dew point for 20 minutes on a meeting yesterday, and people were just like, I'm done. I gotta go. Yeah.
Yeah. So 75% of the precipitation, this is another factoid for Tucson, 75% of the rain in Tucson happened before the last week in July. So really, really heavily front loaded there. Okay, I'm looking at the time, and I think we should move on. Anything else that you want to say that was maybe interesting to you, or should we move on, talk about hurricanes?
Yeah, let's do hurricanes.
Okay. All All right, so maybe put this into some perspective here, right? Like coming into the Atlantic and Pacific hurricane season, the big story really was how much activity was being projected, at least in the Atlantic. All of the forecasts, and there's quite a bit of them now, were calling for way above hurricane average hurricane or not hurricane average tropical storm activity. So on average, if you look at the 1991 to 2000 year period, there is on average 14 and a half named storms in the Atlantic, 7 of which are hurricanes and 3 of which are categories 4 and 5, right? So these forecasts, right, they start like around April, right? From like Colorado State University, NOAA, U of A has one, and others. Penn State now has, University of Pennsylvania has one now. They were like 20, 23 for named storms, 21, 26, right? And then so fast forward that to May, so a month later into early June, right? So June 1st is basically when the Atlantic hurricane season starts. They were even a little bit more bullish. So NOAA had a very large range, but 17 to 25 named storms. Colorado State had 23. University of Arizona had 23. All right. So that's where we sort of came into the season. A lot of those forecasts, I don't really understand how the models, I mean, if they're dynamical or if they're statistical or whatever, it's not my thing. So I don't know exactly how they're doing. It's probably a combination of both.
Yeah.
But as I understand from the reading, a lot of this was being driven by really exceptionally warm sea surface temperatures, like historic, generationally warm, right? Like I think, so last year, 2023 was bonkers across the North Atlantic. So from the equator to the north, 60 degrees north in the Northern Hemisphere. Last year was like record for almost the entire year. And this year, coming into like mid-May, was even warmer than on average than last year was. And it's since dipped in July and August, June, July, late June, July, and August. But it's still like the second warmest on record. So, and then of course there was another part to this, which was and that was the transition from El Nino to neutral conditions, moving into La Nina, which tends to reduce shear in the Atlantic, which helps storms grow and that sort of thing. So really high forecasted tropical storms. And let me just say one other point before telling you where we are right now, and that is the sort of peak of hurricane activity is September 10th. September has the most activity on the order of 6.5 named storms. October is about 4. November drops to 1. So September is the peak. I guess I should also say that August is similar to October in that it has 4 on average named storms. So we're past peak. So currently, we've had a total of 7 named storms and 4 hurricanes, 1 major hurricane. Some of the metrics, Mike, like if you look at the accumulated cyclonic energy and just not like frequencies of the storms, they're closer to average, but that's in large part fueled by Beryl, which was a very long lasting strong hurricane. So if you take away Beryl, like by almost every metric, the Atlantic hurricane season hasn't sort of lived up to its expectations. And yeah, we still have a little bit of September left and October left, but we're not going to get, it's hard pressed to see that we're going to get close to what the forecasted values were. What else do I want to say here? Oh, so that's led a lot of people to speculate on why. And there's sort of like four working ideas here. So there's been the observations that intertropical convergence zone in Africa is further north than it's actually, migrated further north than it usually does. That kicks off easterly waves, atmospheric instability, which then ultimately generates these locuses of convection, which can turn into hurricanes and tropical storms. That basically kicks them off further north. So then they traverse over colder water because you're further north. And you actually can entrain drier air. So that's one thing. There's been more Saharan dust episodes this year, and the dust can actually have a suppressing effect on the hurricanes too. You mentioned this earlier in relation to the dynamics of the monsoon, and that being that there's been warmer air aloft, and that has suppressed the atmospheric gradients from the surface upwards, which suppressed hurricane activity or tropical storm activity. And there's actually been more shear than what's been anticipated.
Yep.
So I don't know. It's not my place to figure out which of those are going to play out. I don't know. I guess I would side with some combination of all of them. I suppose they're all backed by like observations, like these things are actually occurring, and right, like you can look at NDVI and look at vegetation greenness, and like in North Africa, and it's way greener further north, and it's not as green typically where the northern extension of the tropical convergence zone is. So right, like we actually know that the position is further north, but yeah, and I think that's kicked off quite a bit of interesting, I don't know, discourse, right? Like,
yeah, totally. Yeah,
I think
the media has really picked up on this quite a bit too over the last couple of weeks.
Right. And so the media, though, on the one hand, at least what I'm reading is like it's actually trying to unpack the causes of this. But I think that subtext to this from the more cynical parts of the web are like it like calls into question the credibility of like climate scientists, right? Conflates itself a little bit with the climate change narrative. And to me, the thing that I see is like people are forgetting like the main point of one of the two main points of these predictive models, right? Like obviously we want to predict the future to save lives and that sort of thing, right? Particularly like these extreme events. But the other thing is like it's a learning tool.
Yeah.
And the failure, if you want to call it that, of the forecast is probably a good thing. Like what did we miss? I don't know. Yeah. So I just think it's like these are opportunities to figure out like what parameters we got wrong. I mean, we certainly don't have the atmospheric dynamics of these hurricanes like pinned down to a point where like our forecast three months in advance are going to be like pretty darn accurate. Like maybe in some years they'll be pretty good, but there'll be years where they probably less frequently they'll bust. But the question is why.
Yeah, I think that, and these are interesting types of forecasts, right? Like those groups that you talked about at the very beginning are, they're seasonal in nature, but they're counts, right? Like they're tallies of discrete events that are going to occur over a season, and we don't really do that with many other things. Like there's no like at the beginning of tornado season that I'm aware of, like we're going to end up having 200 F0 tornadoes and 100 F3s or whatever, that kind of stuff. So I mean, like this is a tough thing to do right out of the gate, right at the beginning. But the Colorado State group has had some success in the past, and I think it's largely statistical. Looking at counts from past years with overall patterns and those kinds of things. And so I think it's to your point is that, I mean, climate change has clearly got to be part of this, right? And there's dynamism in the system that makes statistical models sometimes problematic. Like if conditions have changed out of that period where you've calculated all of those statistics, they're not going to be as reliable in a forecasting manner every year. So yeah, I've seen like headlines of this of being the hurricane forecast a bust of historic proportions and that kind of stuff. So I think, yeah, like to your point, this is hard. It's a tough business. And as long as we're learning from it, like that's probably the most important thing.
I mean, it's reminiscent a little bit of, God, what was the last major Godzilla El Nino? Was it 2015, 2016?
Yeah, yeah,
It's a little bit reminiscent of that in our area, right? Like
yeah, yeah,
massive forcing, right? Like much of like, if there was any moment to go, big on the forecast or to like be confident in it, it might have been that year. And
yeah.
it turned out like not to produce what you might have otherwise thought. And certainly this year, I mean, what was striking though about this year is like just how much more counts of storms that they were forecasting than is average. I mean, this isn't like, 16 to 18. It's not like above average, by 2 or 3. I mean, it's above average by like, 8, 10. Some of them, Jesus, UPenn forecasted 33 named storms. That's
Yeah.
like,
Okay, so this is maybe cynical, but do you think that there's some temptation to try to want to like I must kind of feel like it's like a bet, right? Like to try to like out count the other forecasts and to like lean into it and like they're putting all their chips like everything is converging on this and like we're going big on this, or is that overly cynical? It's probably
well,
cynical.
I mean, you would think that they're adhering to some measures of scientific credibility, right? Like,
Okay. That's probably
that they're going to
reasonable.
be judged, that they're going to be judged, yeah, their reputability and their credibility will be judged by like how well they do. So, but I mean, yeah,
33 name.
yeah,
That is
it's strange, and I haven't seen that group. I don't know who that
yeah.
group. I mean, obviously they know a lot.
They're new. I mean, like this has popped up over time too, right? There are more and more groups kind of in there.
Yeah, it's true, right?
Yeah.
Noah's always funny. It's always like a huge range.
Well, and Noah's the most conservative, right? And like they're not going to do something like 33.
Right, right. I guess I should say, so I did check. It is Alberto. So
Okay.
just clean that up from before.
Yeah.
So if you were to look, okay, so we've had 7 named right now, and you're like, okay, so if we got average going forward, where would that put us? Well, basically from the traditional, the historical evolution of the number of storms from September 16th to the end of November is 1, 2, 3, 4, 5, 6. So we'd get something like 13, which would come in at below average. All right, so I know we're running out of time, Mike. I wanted us to finish like 3 minutes ago, but let me just give us an update on, we care more about the East Pacific. And the forecast for the East Pacific coming into the season made in May, a lot fewer organizations. In fact, just one from Mexico and NOAA make the forecast there, I think, or at least that I'm looking at right now. Average named storms 15, so a wee bit more than in the Atlantic. 8 of those hurricanes and 4 major hurricanes. The forecast coming into the season was 15 to 18 by Mexico and 11 to 17 by NOAA. So maybe a slight tilt toward, well, probably let's just say it's average.
Yeah. Yeah.
East Pac, we've had 9, and the Central Pacific, we've had 1. So we're at 10 right now. Again, if you were to sort of like spin that forward based on like, well, if we just did average going forward, how many would we end up with? We tend to get, 1, 2, 3, 4, 5 more. So we're pretty much right on average there with the East Pacific. So we might, and maybe that plays into a little bit of our late September, early October or October kinds of weather. I mean, there's still, 5 more of these things spin up in the East Pacific, going forward, Mike. So anything on the horizon there that we might change, probably won't change the monsoon season, but maybe impact us. Anything?
Well, yeah, I just looked at one of the forecast models. The GFS goes actually out to the beginning of October, and so it does spin up a East Pacific hurricane at the Gulf of California on like October 3rd. So it wouldn't even count in the monsoon total. We're now into October, and again, it's fantasy at like 300 plus hours on this.
All right. So probably not a game changer there by any stretch.
No.
All right. Well, maybe just a quick hint at what our winter forecasts were doing. Then let's wrap it up. Let's say goodbye to the monsoon, right?
Yeah. I mean, there's a La Nina, Zach. Kinda, maybe.
Right. Actually, hasn't it been?
Yeah, it's been all over the place. And so I think that's what we're going to talk about this fall, is to try to look at these La Nina forecasts and try to just kind of talk about what's been going on with ENSO over the last couple of years. And
has it becoming less predictive?
Was it ever predictive? Maybe that's the better question. It's interesting that we might be, I don't know. We had an El Nino last winter. It's not uncommon to be followed by a La Nina event, but the forecast models have just had a terrible time trying to decide on when this is going to start, if it's going to start, how strong it's going to be. And then we got to think about if it's going to actually impact our weather or not. The forecast models right now, the seasonal models, the national multi-model ensembles are boringly forecasting below average precip because of that El Nino signal. But as we know, that's not always the case.
Yeah, so the most recent ENSO forecast, mid-September, from International Research Institute for Climate and Society at Columbia, does give elevated chances for La Nina. So it's like 60% in the November, December, January period, drops down to 55%.
Yeah.
Basically nothing, 0% for an El Nino, right? So it's the trade-off between is it going to crest the threshold for a La Nina event or stay in neutral? And if you look at the dynamical models, the average of the dynamical models actually is just slightly below the threshold. So it would be an La Nina. But the statistical models the average of the statistical models don't actually cross that threshold. So there is, so it's like an interplay. Now, there are these two forecasts. There are the mid-month IRI forecasts, which are just like model driven. And then there are the beginning of the month, which are model driven. And it's like an expert forecaster, making some tweaks to the forecast. And with the forecaster behind the wheel, it's slightly higher chances for a La Nina. So I think they're maybe weighting a little bit more the dynamical models than the statistical models. But I don't know. I think, has the trend sort of moved less confidently, toward more of the sort of equal probability than, yeah.
Yeah, I don't know. I mean,
for those not watching us, we have a YouTube channel.
We do? Oh,
No.
God, we shouldn't.
No, you just shrugged there.
Yeah, I did. You're right. Shrugging on a podcast, not super helpful. Yes.
Yeah. All right. So anything else there, Mike, on the forecast?
No. I did remember the thing that I should have said earlier about the monsoon with the wrap up, that final thought. I think it hottest on record probably for many locations. I think I buried that deep. I didn't want to think about it, but yeah.
That's right. We tend to focus on the rain.
We do, but the temps were a huge story this summer and pretty miserable.
I'm glad you brought that in. I'll have a final parting shot too. So just looking under the hood of the models for precipitation for the October, November, and December period, and all but one of them, all but the NCAR CCSM4 has a below average signal. So all 6 of the 7 and if you include the international multi-model ensemble, 7 of the 8 have a dry signal. So
Totally.
yeah, there you go. All right, Mike. Sorry for running a little over.
We're good.
right.
Yeah, happy Monsoon 2024 to
Yeah, in the
everybody.
books. In the
Yeah,
books,
in the
that was
books.
good.
Yeah,
Oh,
we'll
you
start.
know what I never got to? Dang it. I'll have to
Monsoon Fantasy.
no, like
Yeah, too.
I wanted to get this in earlier. I'm done with September.
I know you are.
Yeah. So give me a minute here.
Okay.
All right. So here's my rationale. So the monsoon is basically at most like a 2 month phenomenon, right? So I went back and I looked at, I mean, this is not very in depth, put it that way, but
Is it eyeball regression?
it's worse.
Oh, it's worse.
And a small sample. But I went back and I was like, okay, give me the three wettest monsoons on record. Again, I'm focusing on Tucson because I didn't have a ton of time. But the 1964, 1955, and 2021 are the 3 wettest monsoons on record. And so 1964 basically starts July 10th, ends maybe September 15th. Basically a 2-month period. 1955 starts mid-July, ends like end of August, so 6-week period. 2021 starts basically July 1 and is more or less done mid-August. I mean, it's just there. It's not a long period. We extended out, and this year it was more or less 6 weeks. If you 5 weeks if you don't want to include the Alberto signal, and almost two months if you do.
Yeah.
Right.
Yeah.
So, and September is, I mean, like what happened this year, you get something that knocks the ridge out of the way, and it's not coming back.
Yeah, I mean, it can try to come back, but it's not in that consistent way. And yeah, I'd probably talk about it a different time, but it's just like thinking about that dew point. Sometimes that dew point trace will hang on through September, and so you can still kind of get kind of thunderstorms, but the overall pattern has maybe moved on from the monsoon. So you can kind of get these kind of hangover storms that are technically during the monsoon season, but they wane really quickly in the first 2 weeks, even under ideal conditions. And it's usually tropical for anything that's substantial in the rest of the month.
Dang it, I wanted a longer segment on this. But do you buy my let's throw September out?
I think this is a two-parter next summer where we have like a counterpoint. We have to debate each other and argue the pros and cons.
Going back to like Tucker Carlson and
And
Paul Bagala.
yeah, that's right. I was thinking the old William F. Buckley days. Yeah, let's do it.
And I know we're overtime, and Mike, thanks again for these conversations. Stacy, thank you for producing this, and thanks to all the listeners for at least allowing us to speak at you for a little bit of time.
That's right.
Hopefully it's entertaining.
Yeah, happy monsoon again, and on to fall and on to thinking about the winter.
All right, let's do it.
Thanks, Zach.
Bye-bye.
I don't feel bad. I don't feel lonely. I'm just glad it's over. I don't need your love, I don't want it. Heaven's up above, and I'm upon it without you. Without you, I don't wanna kiss you again. Can you believe it? Don't wanna be your friend. I just want you out of my I got nothing to say to you anyway. I said what I meant, to put it mildly. I hate you 100%. I mean that kindly. Oh, you're not for me. You're not for me. I don't feel bad. You're not the only one I've ever had. I don't feel sad. I don't feel lonely. I'm not even sorry. I'm just glad it's over. I'm not playing with you. You're just here.